can get going. Okay, everything is starting. So basically tonight we're gonna continue with study unit 5. We'll finish it, I think, around 6 o'clock. Um, and then we will also start with study unit 6 and see how far we can go with that. Also, I see that most of your assignments will be opening next week, so we can have another session early next week again to just make sure that you're ready for assignment 2. Yes, okay. And then just I have also on the chat there's a link to just complete for me, please, the attendance register during the evening. So you don't need to do it now. You can do it later as well. Okay, so last time we started looking at discrete probabilities. Within discrete, we've looked at some random variables, random discrete. We also looked at binomial, and nearly the last part was that we needed to look at Poisson. I have sent some of the slides in the WhatsApp as well. I'll also just, for anybody joining for the first time or not on a WhatsApp group and wants to join the WhatsApp group, the number is also now in the chat for you. So just please send me a WhatsApp if you want to be part of the chat. So we looked at discrete. We basically looked at how to work out expected value and variance when it was around the discrete probabilities. I used in some of the instances Excel again. Then we went into binomial. We also looked at, and let's skip that. Let's go to where we had the examples. We looked at in the normal discrete. We looked at probabilities, but also in some instances where we also needed to work out the expected number. Then we looked at binomial and how to use the tables that they give you in binomial. So there's one more question on binomial that we're going to go through tonight, and then a few on Poisson. Okay, so in binomial again, what is important is they will need to give you the n, so that you can on the table know that, okay, I'm gonna work with n equal to 4. They need to give you the pi, or the probability that you're working with. So there they give it as 0.2. So and just for making it easier, we're gonna work in that block. And in this instance, they just ask you to look at a problem. So they're telling you, okay, you've got n is equal to 4, you've got the pi is equal to 0.2. Now give back the answer where x is bigger than 2. Okay, so there's 2, it will be that one, but we're looking for x bigger than 2, so it's excluding 2. So we're only going to look at that last 2. So the 3 and the 4. If it was, oh wait, and we are making a mistake. It is actually not bigger than, it's smaller than. So I want actually to work out smaller than 2. So I need to get the 0 and 1. The 0 and 1 is those 2. So basically 0,4096 plus 0,4096. Okay, so they told me smaller than 2. Smaller than 2 is 1 and 0. So I will add those 2 together, which will be the 0,8192. If it was smaller or equal to 2, then it would have been from 2 to 0. Then it would have been those 3, and then it's probably going to be that answer. Let's quickly check. Yeah, then it is going to be option 2. So if it was including 2, then it would have been option 2. So let's just write it in here for you. If it was x smaller or equal to 2, this would have been your answer. The other 2, that would have been how I first looked at it. So if I said the probability of x is bigger than 2, it would have been 3 and 4. That would have given me option 4. So there's nearly for a few of these, there is options that you could have picked. If it was only x equal to 2, it would have been that one, the 0,1536. If it was x bigger or equal to 2, it would have been option 3. So you can really see for a few of the different ways to write it with 2, it could have been any of those answers. So again, very important when we look at the table that we 100% understand what we are looking for, because by just looking at it a bit differently, you could have gotten any of the other options as an answer. So it might look very straightforward, but it can also be confusing in the answers, because you can very easily, like what I now first did, was to, I don't know why I did it. It's not that I read it wrong even, but I just looked at the first 2, and that would have given me an answer. So if I didn't realize I'm making a mistake, I would have add one of these options. And again, when we in an assignment, it's fine if you make a mistake when one learns out of it. But if it was exam and I made that mistake, you're thinking you got it right, and then not. So just again, very careful when we do this. Another one that we can look at. So let's see what is in here. So according to a report from the Center for Study health system change. 20% of South Africans delay or go without medical care because of concerns about cost. Okay. Suppose 6, so now they write it down. So I was looking for the number. 6 individuals are randomly selected. So your N is equal to 6. Your pi is equal to 20 or 0.2. Then they ask us, what is the probability that more than 4 will delay or go without medical care? Okay, so what is the probability that X will be more than 4? And so again, if N is 6, we've got N is 6. Let's just, I should have, this would have been 0.2. Should be on the table. I don't know why it wasn't copied with. So that will be where pi is equal to 0.2. If I'm only looking for bigger than 4, I'm looking at 5 and 6. Then if I add 5 and 6, I get 0.0016, which would have given me option 4. If I only looked at X equal to 4, I would have gotten option 3. If I looked at X smaller or equal to 4, it would have been that one. If I looked at X equal to 5, would have been that one. So there's nearly for each one, again, in some weird way, there's an option. That one, at least, I don't know where they got. Oh, if you looked at X4 and 5, 1.6 will give you 1.7. So if we looked at X4 and 5, we would have had option 5 as the answer as well. So again, very careful when you nearly write it out. They could have also said the probability that more or equal to 4, then you know you need to add the equal. They could have said, what's one of the other ones that they use a lot as well? Less than, I think in this. Okay, so yeah, it wasn't set less than, but if I said the probability that less than 4, then it would have been less than 4. Okay, so not equal to included, just less than 4. So again, depending on what they ask us or what they tell us, we look at the table. And again, for me, you have in your study guide the binomial. If you can get that tables nearly printed out somewhere, because that will also help you in the assignments and in the exam, when you look at the tables, to nearly work with it and draw on it and mark which ones you're looking at. Again, I know it's not always possible for you to get some of the pages printed and those kind of things, but if you can, please do that, because it really helps a lot if you have the table next to you when you do these kinds of problems. Also, you guys are allowed to use online sources. So if there's a binomial website that you want to use, by all means, do that. And you can also input a lot of these numbers into some of those online tools. Okay, the next one will be then on Poisson. So the big difference between Poisson and binomial is that in Poisson you will get a time frame added to the question. So if we look at the binomial questions, it just every time said, okay, an event is going to happen, and you need to nearly then work out the probability if so many out of a total happens. But then when we look at Poisson, again, we look at an event might happen, but there is a time frame always linked to it. So it can be per second, per minute, per day, per week, per month, per year, but at least there will always be a mention of a time linked to it. Okay, so in this one again, if we look at Poisson, what they tell us, calculate the probability. So again, it's very easy to pick up the 1.8. It's very difficult when we put it into words. So calculate the probability that 3 bank robberies occurred in a day, where the number of bank robberies that occur in a large Gauteng city is Poisson distributed. So in this instance, they tell you the mean is equal to 1.8. So when you go to the table, you will know that it is 1.8. Then when you look at this, what's the probability that exactly 3 bank robberies occur? So what's the probability that x is equal to 3? X equal to 3 is 0.1607. Okay, so it is option 3 in this instance as well. You can see that is referring to 0. That is referring to 1. Let's see what else could have been. That could have been probably 3 or more. So again, depending on what you add to that, it could have been option 4 or 5 as well. But in this instance, they said, what's the probability that 3 bank robberies will occur? If I said less than 3, then it would have been 2, 1, and 0 added together. If I said 3 or less, then it would have been those 4 that you add. If they said x bigger than 3, it would have been from 4 and up. So x bigger than 3 would then be 4 and more. If I said, I'm just looking at a few options for you guys. So if I said x bigger or equal to 3, then it would have been from 3 everything upwards. So again, you can decide. So if I needed to work out this one of x bigger or equal to 3, you need to add all of these together, which is, what is it? 1, 2, 3, 4, 5, 6, 7. So you need to add those 7 probabilities. What you could have done as well is to say 1 minus, and then you add the probabilities of the other 3. Okay, so it could have been, to work out your answer, it might be quicker to then say 1 minus the other 3, because in the end, all of these probabilities will, when you add it all together, must be equal to 1. The same in your binomial, and it doesn't matter where I am, all of that needs to add to 1. If you add all of that together, you will get 1. If you add all of these together, you will also get 1. So the same with Poisson. If you work with the mean equals to 1.8, all of that will equal to 1. If it was lambda equal to 5, all of them will also equal to 1. So it's just important merely to see that in perspective, so that if you only needed to work out the first 2, or if I needed to say x bigger than 2, what's the probability of that? It's easier to say, or say x bigger or equal to 2. So instead of, again, adding all of those together to get an answer, it's easier just to say 1 minus 0.1653 plus 0.2975. So I would have preferred to do that instead of saying 0.2678 plus that plus and getting an answer. So again, just a tip, but do as you would prefer. So again, if you want to add all of them together, or if you're using a calculator or something that has it built in, again, rather use it as you prefer. Okay, then the next one on Poisson. So yes, they tell us Poisson, but again, there is the time frame with it linked. So in this instance, per month, they tell us again lambda is equal to 2.5. So we can go to the table with 2.5, and they tell us that, okay, it's Poisson. We used a model, the number of fault in a gearbox. So you can again see fault, so it's happening or it's not happening. Suppose the faults occur at an average of that. What's the probability that at least 2? Okay, so at least 2 means that, so let's just, that's 0, that's 1, I don't know why that has also fallen off. So at least 2 means 2 or more. So I need to work out what's the probability that x is at least 2, so 2 or more. Okay, so now here we have the instance. So I need to add all of them together to get the probability, or I can say, well, it's easier to say 1 minus these 2. So let's say 1 minus 0.0821 and 0.2052. So if I say 1 minus those two, I will get that my answer is option 1. So it would have been 1 minus 0.2873, which would have given us the 0.7127. If you add all of these together, it will give you that as well. But the chances is bigger than that we miss some number here or some decimal. Um, Luckily, what you will also see, you will not get an option that is 1,7,126 or 1,7125. Just if somewhere, if you added all of that and somewhere it was rounded off or something like that. So if you then get 0.7126 or 0.7125 or 28, there will not be an option like that as well. What happened here is they just swapped the 7 and the 2 around, but there would not have been a way nearly how to get that with these numbers. Okay, so again, nearly look at what's the easiest way for yourself to work it out when they give you this information. The thing that they will ask or do a lot of times is around that 2, they will give you some options as well. So if you selected 2, there was an option. If you nearly select 2 and 1, there might be an option. So just be careful every time around that point that you need to look at. There is answers as well. So be very clear on what the question is and how you need to look at it. Okay, then what I've also added is a question where they throw in something that they call that's variance. So again, Poisson, we know that lambda is equal to the mean, but also equal to variance. Okay, so in this instance, that variance that we had should have been equal to 6. Okay, so that one is incorrect. This answer is actually a standard deviation. But again, from the definition, your lambda is equal to mean equal to variance, not standard deviation. So with that, we definitely then know option 2 is wrong. But let's look and work out for others so that we can just get that out of the way as well. So if we looked at that is 6, so if we were looking for x equal to 0, you can see that is the same, so that would have been correct. If we look at x smaller than 3, so let's use a different color. X smaller than 3, so x smaller than 3 is those 3 numbers. So if you add those 3 numbers, you will get that answer. So it would give you the 0,062. So x smaller than 3, we're not including 3, so 2, 1, and 0. Then if we look at x bigger than 5, x bigger than 5 would be all the way from 6 and up. So again, I would probably rather say 1 minus probability that x is smaller than 6. But yeah, it's nearly either or. You're gonna need to do a lot of calculations. But if we quickly looked at 1, 6 plus 1, 3 is 2, 9. 2, 9, 3, 7, 3, 7, 4, 1, 4, 2. That actually looks wrong. 2, 9, 3, 7, 4, 1, 4, 2. That even might be also wrong because it might even include that one. Okay, so that is quite interesting. We need to check that because that might also actually be wrong. I'll work that out now with the calculator, but I'm looking at that. 2, 9, yeah, 2, 9, 3, 7, 3, 7, 4, 1, 4, 2. So definitely somewhere here there was also a wait, no. So 1 minus 4, 7 will give you that, sorry. Okay, so now that one is, I was just looking at now that part and not the 1 minus, so that would be fine. So that's also right. And then if I look at x between 5 and 2, so smaller than 5, but bigger than 2. So it's only then 3 and 4, and that would also then be correct. So again, if we add, if it was small or equal to 5, we will include 5. If it was bigger or equal to 2, we would include 2. So depending on, again, which one or how they show it to us, we just need to make sure that do we include it or not. And again, that will then differ or make your answer different. So again, if it was in this instance x smaller or equal to 3, we would have included probability of 3 as well. So they can nearly ask this in a few ways for you. Then the last one on Poisson, they again give you a question, then here again a different way of phrasing it. So this was a lot of symbols that they used. Now they're putting it into words. I normally don't like it, but let's first look at the options, and then I will probably write this out for you as well, because I don't like looking at things in words, because sometimes how they phrase it, I just don't like it. So let's look at a cashier at Carter's cafeteria can total an average of 1.2 trays per minute. Okay, so per minute means that it is Poisson. So in this instance, they didn't tell us it's Poisson, but because it is something happening per time, it is Poisson. So incorrect. Problem follows a Poisson distribution. That is correct. Okay, then it asks us, so it tells us the average is 1.2. So it says the variance of this problem is 1.2. So we know if the average is 1.2, that's the same as lambda, and that's the same as variance. So the variance is 1.2 is correct because the average or the mean is also 1.2. Then they tell us the probability that the cashier would total exactly 0 trays per minute. So what's the probability of x exactly 0? Okay, exactly 0. Looking at the 1.2, exactly 0 is 0.3012. So that is correct. Okay, 0.312. Then the next one, the probability that the cashier would total at least 4 trays. So what's the minimum of trays that the cashier needs to total is 4. So at least 4, so it can be 4 or more. Okay, so 4 or more. Again, now we can decide which way we want to add. Yeah, I see the last two is 0, so it's actually only those ones that I need to add. So 2, 4, 6. So already there's a rounding off error that is going to happen. But so let's see if I add it to this side, it would have been 2, 4, 6, 12, 13. Okay, so 0,0336, so very close to that answer. If I went the other way of 6 and 6, it would have been 12. So it would have been, if I set 1 minus those ones, I would have gotten the 0,0338. So again, it should be the same. Doesn't matter which side of the tables you're nearly using, but because this is rounded off, now there's that small gap in the answer. So again, if you're getting something like this in the assignment, you can let me know, and I will just send the lecturer a message. So if you see it in the assignment, just let me know. Question 4 of assignment 2 there is when there might be a rounding off error, and I will just let the lecturer know, because again, it should not be like this. So I normally check it out beforehand, but if there is an issue, let me know. Also later on in the end of the year, when there's things like this in the exam, also important that you nearly let me know around that. Okay, so that should have been correct. The probability that the cashier will total at most 3 trays. So now what's the probability at most 3? So then it is x smaller or equal to 3. So actually, if we, that's interesting. So if we added that, we should, yeah, so the answer should have been 0, 0, so it's 6, 6, 8, 7. So this answer, it's actually only looking at what's the probability of x smaller than 3. Okay, so we need to add the 0.0867 to that to get the final answer. So that's why this one is wrong. So this one, to get to the 0.8795 was x smaller than 3, or it could have been written as well as x smaller or equal to 2. So again, a few ways that they can talk about it or write about it. Okay, so that is looking at your Poisson distribution. And again, it's easier to use the Poisson distribution table than looking at, and let's just zoom in on this, than looking at this formula for Poisson. So imagine you needed to do one of those questions where you need to use this formula for x is equal to 0, 1, 2, 3, and 4. Then you need to make 5 calculations with this formula, which again, yes, you can, but it takes time. And again, in your exam, you guys will not have enough time to do this formula for a question where you need to get or work out 4 or 5 probabilities. The same, like I said last time on binomial as well. Rather, we'll use the and I probably didn't even know where it is. Rather that we use the formula, rather that we use the table than trying to work out by using the formula. Because again, if we needed to work out the binomial probability for 3 of the x's, you need to make this calculation 3 times, which takes a lot of time, and very easy to make a mistake in this. Okay, so that was on study unit 5, where we looked at random variables, binomial, and Poisson. Questions around that. So again, when it's discrete, it happens, and you would have now seen it in all of them. We would have set x equal to 0, x equal to 1, x equal to 2. So it didn't matter if it was discrete. So let's just quickly show it again to you guys. So it didn't matter if we had it the discrete where it is 0, 1, 2, or 3. There isn't a 1.5 or 1.6 or something in between. The same when it was binomial, it is x is equal to 0, 1, 2, 3, 5, or 6. There's nothing of a 0.5 or anything in between. The same with Poisson. It was x is equal to a discrete number, which is a 0, 1, 2, 3, or 4. Okay, so that was chapter 5. In chapter 6, this becomes more continuous. So, and that's why it's called normal continuous distribution, because we are looking at everything between certain numbers. Okay, so, but let's quickly, are you guys comfortable with binomial, Poisson, and some of the random discrete variables? Any questions around that you want to ask? Okay, so when I'm gonna start, that we start with normal distribution. So in normal distribution, let's just make this way bigger. And I have shared this also, these slides so long in the WhatsApp, so that you also have it. But what we are going to focus on is normal distribution. So for both 1510 and 1610, we only going to focus on the normal distribution. In some of your textbooks and in some of your study guides, there might be reference to uniform and exponential. We're not doing that. So we are only focusing on the normal distribution. So also, if you go way back in some of the exam papers, there's the uniform and the exponential. Just don't worry about that, because it is not a focus for you guys. So only normal distribution, and then please don't study this formula or anything to do with it. You're not going to use the formula. It is just to show you how the normal distribution formula looks like. But please, we're not going to look at that or use it in any form. So again, we will use normal distribution tables so that you can really get the answers from that. Hey, then the other thing that is important with normal distribution, and as we go through study unit 6, but also 7, we'll still look at it even in study unit 8, is that as with the binomial, Poisson, and discrete, that the probability all added to 1. The same with a normal distribution. So with a normal distribution, everything under the curve adds to 1. So the probability will always add to 1. What makes normal distribution a bit different is that when we have a normal distribution curve and your mean is always in the middle, to the one side, it basically halves the normal distribution. So to the one side, you will have 0.5, and to the other side, you will have 0.5. So what they sometimes say with the normal distribution is that mean that's in the middle, you nearly have a mirror image on both sides. So whenever we're going to look at it and we've got a mean that might be 1.6, the same will happen on the other side at minus 1.6. Okay, so just remember nearly this mirror image that happens, and what they call it in stats is that you've got the normal distribution is symmetrical around that mean. So basically what happens on the one side of that mean will always happen on the other side as well. So it might be in some of the theory questions or things like that. They might ask you a few things, so they might tell you or ask or say a statement like the probability will add to 1, which is correct. They might say that a normal distribution is symmetrical, which is correct. And we will get another few of those types of things that they will also tell us about normal distributions. Okay, then again, we're not looking at exponential, but to see how it was curved. We're also not looking at uniform, but to see how it's curved. This is your normal distribution. So again, normal bell-shaped is the other word that you will see in the study guide and in your textbooks. They sometimes call it bell-shaped as well, because it looks like an old school bell nearly of the 60s. So that's why they call it sometimes a bell-shaped curve as well. Then the other thing that we'll see is what they sometimes call it as well is continuous probability. Because we are looking at the probability, say, between x is 0 and x is 2, and there it is, because it's continuous, it can be anything between 0 and 2 maybe. So it's not where the previous chapter was 0, 1, 2. Here it can be anything. So it can be 0.11111 up until 1.999 or something like that. So very important just to remember that with normal distribution, it is a continuous distribution that we are looking at. So it nearly takes us back to, what was it, chapter 1, chapter 2, where we looked at continuous and discrete. So the continuous, we just now taking a bit further. I'm going to skip that. So the other thing that we can look at, and again, so that was the same as on that first slide. We're not going to use this formula. It is just there so that you know about it, but we're definitely not going to use this formula at all in any of the assignments or any of the exam questions. We don't need to use that at all. Okay, so here we talk about the symmetric. So one of the characteristics that's symmetric. Remember also, I think it was in chapter 2, chapter 2 and 3, where we said something is, or we might not have used the word symmetric, but we would have said that the distribution where the mean is equal to, let me just get this right again, where the mean is equal to the mode and is equal to the median. So that goes back to, still don't know why my computer does this. So that goes back to chapter 2, chapter 3. Mean, median, mode need to be equal. When that is equal, we have a distribution that is symmetrical. So that will just mean that both free mean, median, and mode is sitting there in the middle, and then we will say it is symmetrical around that point. Okay, so that is one of the characteristics. The other characteristic is, and this we will use a lot in chapter 7 and 8 as well, is that we talk about it as the mean. So that is your mean. And then we will work around it with a standard deviation. So when we get to chapter 8, that standard deviation we will start using in confidence intervals. So chapter 8 and 9, we will start using that standard deviation linked with the mean in confidence intervals as well. So you nearly see the importance of this chapter going forward, because we'll use normal distributions when we look at confidence intervals. We'll use the normal distribution when we do chapter 8, I think, with hypothesis testing. So a lot of this in chapter 6 is important for going forward. So I talked about the mean, median, and mode, which is in that center spot. That center spot it goes with the highest point in that curve as well. So when we work that out, we can call it and say all of the things are similar at that point. So you can see we going through a few of this, just if they might ask you something like this as part of the nearly theory part of normal distribution. So the other thing that can happen is this mean that we have, because it's continuous, it can also be negative. Because it's continuous, it can also be 0. So remember, in discrete, binomial, Poisson, only 0 and up, because we can't have a negative event. But with your normal distribution, you can go negative. So remember from that, and how do we just want to, I'm spelling it wrong there. But from chapter 2 and 3, continuous, we can go negative. So again, just sometimes when there might be a negative answer, doesn't then mean it is wrong. So normal distribution can have negative answers in it. The other thing that I just also want to highlight is, so the smaller your standard deviation, the higher nearly, or how can we also say it, the more squashed in your bell-shaped curve is looking. So the higher, the flatter it is. So when you look at this one, much steeper with the standard deviation of 15, with a standard deviation of 25, much flatter. So if you had one that is equal to, say, 35, it would have been looking, again, something would have gone something like like that. Or if it was um, 10, it would have been something more steeper like that. So again, depending on how big that standard deviation is, will be dependent then on how that curve looks like. So again, not important, but just for a type of theory question that one can look at. We've done that in the previous one. I've added this just because I've seen this portion sneaking into why just say this. Just worried that something can. So then there it is back. I've seen it in assignment questions where they talk about 1 standard deviation, standard, 2 standard, and 3 standard. So it might happen again in your assignment. But if we look at what we've said here on a graph, basically it looks at, so your probability between those 2 points is around 68% of your values will lie between 1 standard deviation, 95% of your values will lie between 2 standard deviations, and nearly all of your values, so 99.72% of your data will lie between 3 standard deviations. So again, I have seen that they ask something like this in assignment, so just take note of this. And they nearly have asked it as this. So they would have given you 4 or 5 statements like this and said, but which one is incorrect? So just be aware of this. And again, I will share this after the session as well, both the updated study unit 4 or 5 and 6 that we have worked through, so that you just have some of the scribblings on it as well. The thing that you will also need to do is, and I just want to see where I've written the formulas. So we will work out what we call, or we will convert the normal distribution into a Z value. So the information that they need to give you is, again, they will need to tell us an X value. So in the discrete, and we always looked at X between or 0, 1, 2, 3, or 5. What we're going to do is we're going to give you a X value. They must tell us what the mean is. So they must tell us, well, the sample mean or the population mean is equal to a number, so that we can work with that. And they need to tell us that there is a standard deviation, which we will need for that formula. Again, sometimes instead of a standard deviation, they can give us the variance, but then we will need to just remember, well, if we square root the variance, we will get to the same answer. So sometimes they might give us the variance, but they need to give us the variance or the standard deviation. What we will then do is we will calculate that Z. So by them giving us that information, we will calculate the Z. With that Z, we will go to the Z table. So let me just see if I just quickly want to go to the study guide. So just give me a second to go into where the study guide is. Oh, I have it now somewhere. Okay, so let me just put it on here. So this is now the 1610 study guide of a few years ago. But in 1610 and in 1510, we will get the normal distribution tables. I just want to, and you will see okay, this one I haven't worked on previously. So we would have now worked out the Z. So in this formula, we will work out that Z. So when we get to examples, when we get that Z, we will go to the Z table. So sometimes we will work out a negative Z. Sometimes we will work out a positive Z. But between these two tables, we will merely look at that we get to an answer. But everything happens because we have a X and a mean and a standard deviation that we will need to calculate the Z. Okay, so that is a bit of background into normal distribution. So is there any questions? So if there's any questions before we go into some of the examples, and there's a lot, so we will definitely not get to all of them tonight. But I'll schedule a session early next week as well that we get through more of this. But any questions at the moment? Okay, so how I look at this, and again, I'm visual, so I need to see things that I need to work out. So here they're telling us using the standard normal Z table, calculate probability of Z bigger than minus 1,65. So here they already tell us it's normally distributed, and we've actually worked out the Z already. So now we need to work out, or just go to the table. But let's see what we need to work out. And so they tell us work out Z bigger than minus 1,65. So in this instance, remember that at that point, that mean is equal to 0. So this side is negative. This side is positive. So we're looking at minus 1,65. So from that point, and we say bigger than that. So I, in the end, want to work out what is this probability. Okay, so let's, again, we're gonna take a bit of time with this, but I want to nearly look at certain things that can assist you. So at the beginning, we said, and I will draw it as well. So we said when we have this, that on this side is 0.5, and on this side is 0.5. Okay, so look at where, again, that number is. So that's minus 1,65. Here was the middle. So in this section already, we have 0.5 of the probability. So it will be 0.5 plus more. So when I look at the answers, I know my answer is already going to be bigger than 0.5. So because it's bigger than 0.5, it cannot be that one, and it also cannot be that one, because now that is 0.04, which is smaller than 0.5, 0.05, again, smaller than. So when I look at answers, I only need to look at 3 options and not 5 anymore. Okay, so I need to look at 0.165, and I need to get this bigger probability. So there's 2 ways, again, we can look at it. So we can go to this table, the negative table. We can say, okay, what is 1,65? 1,65. So how we read this is we go down 1.6 and we go across with 0.05. So 1,65 we can see is 0.0495. So let's just, but remember that portion is that small portion. Okay, so it is that portion that we're looking at. So that 0.495 is that area, 0.0495. So how we can then go about it is to say, okay, if this small portion is 0.0495, the bigger portion, the red area, needs to be 1 minus 0.0495. Why can we say that? Because everything underneath the bell-shaped curve needs to add to 1. Okay, so we could have done that, and then our answer would be equal to 0.9505. Okay, so 0.9505. The other thing that we could have done is to say, okay, but we know, and I need to check what that is. We know that they said we need to find out 1, minus 1,65. Remember when we spoke about it being a mirror image or symmetrical? So this area, the red area, is the same size or the same probability if I did the orange area of going to that side. Okay, so if I look at that, so the minus 1,65, if it was bigger, it would have been that red area. So it would have covered up until there, all the way. But if it's symmetrical, I can look at it from that side and it will give you exactly the same answer. So I could have looked at the positive table where it then looks at that whole area 1,65 and look at that. It also gives me the 0,9505 that I'm looking for. So two ways of doing it. In the exam, you have access to negative table and the positive table. So you can again use whichever one you're most comfortable with. For me, this was the easier way to calculate it because, but again, it it was easier for me because I've drawn the diagram beforehand so that I can see what I need to really work out. But this was the easier way for me to get to the answer with a positive table. But again, it depends on which one is the easiest for you to look at it. So everything in chapter 6, we will basically nearly every time, or they give you the Z and you automatically go to the Z table, or you will need to work out the Z and then go to the Z table. So the next one that we get is a lot of information so that you can work out the Z. And then we need to go to the Z table again. So to work out the Z, we're going to use that formula. So you will, let's see what they tell us. A long distance call or long distance calls made by the employees of a company are normally distributed. So they tell us it's normally distributed so that we can work with a normal distribution. To see now what, I can't get to that, don't worry. So with a mean of 6,3, so they tell us that mean is 6,3. And again, just important, just check. The mean is 6,3 minutes. Standard deviation is 22 minutes, so that at least we're using the same, that it's all minutes. Use normal standard to calculate the probability that a call lasts less than 7 minutes. So what we're going to work out is this Z, that the probability is less than that. Okay, so we're going to say, what's the probability that the Z is less than whatever we're now getting with this answer? If one of these are in seconds, or if it was given in hours, just make everything the same. So if they said instead of 7 minutes to 180 seconds, then we work it out that it's 3 minutes. So just again, make sure that you use the same format for all three of them. Again, that I can do that. So then basically, 7 minus 6.3 is 0.7. It's a weird one. 0.7 divided by 22. So 0.7 divided by 22. Just get to my calculator. So 0.7 divided by 22 is 0.0318. So we will round it off to 0.03 because, again, our Z tables only look at 2 decimals. So when we work out a Z, we will always go to 2 decimals. So we need to work out what's the probability that Z is smaller than 0.03. So that's a probability that we will need to work out. So if I look at the Z table, let's again say that is 0. So in this instance, again, we're looking at 0.03, so just a bit more than 0. So again, when we look at the options, I will know that, again, from 0 downwards, we know that black portion, so let's just make it orange. So that orange portion is already 0.5. And then I'm going to add a small bit to get to that Z equal to 0.03. So my answer that I'm looking for, it's definitely going to be bigger than 0.5. So if I again look at options, that one I can take out because it must be bigger than 0.5. That one I'm going to take out because it must be bigger than 0.5. Okay, so we're looking for that part of the table. So 0.03. So if I look at 0.03, so where Z was 0.03, you can see that is the area that I'm actually looking for. Say it's 0.5120. So, and we've done it here. I've included the table for you as well. So it's 0.5120. And that is the number that we are looking for. Again, you could have gone to say what, but here it is spot on. So it would have been longer to do it, to go to the negative table, but we could have gone to the negative 0.03 where it was that, but then we would have needed to make a lot more calculations, which is not as easy with this one. So with question 2, I would have gone to the positive table. I know that is the area that I'm looking at. It's exactly how I have drawn it as well. So then if I look at the Z equal to 0.03, I can just straightforward read it off the table to get to that answer. So here we actually have worked out the Z. With that Z that we worked out, we went to the table to get the probability that you're looking for. So in this instance, again, what might happen in your assignment or in the exam, one of these answers might even be 0.03. Because, again, very easy when you work it out and you suddenly your eye catches an answer that is close to that, you might stop at that instance and say, okay, I see the answer is there. But we need to, again, follow through. We need to work out probability. So we need to go to the Z table and get the probability. Okay, so that is it for tonight. But you guys can see, and I'll share this again, that all of the other questions, it is following very similar patterns. So they give us a Z. So if we get the Z, we don't need to calculate it, but we can go straight to the Z table. The next question, they don't give us the Z, so we need to calculate the Z. Calculate the Z, go to the Z table. So with all of these questions in study unit 6, you will nearly follow the same principle. It is get information around it. You will need to see if you can calculate a Z value. There's just different ways of looking at how to calculate it. And there might be one or two theory kind of questions as well, but we'll look at that next week. So study unit 6 very much is about looking at the normal distribution and calculate that Z. And when you've calculated the Z, to go and find the probability from the Z table. Okay. Any questions on this for tonight? Hopefully it will make a bit more sense when you guys are going through some of the study material, and hopefully when we've now next week finished this, it also helps you with the assignment. Okay. I will also add the recording. I will download it this evening still, and I will then also upload it to the WhatsApp group. And then again, if you're not yet on the WhatsApp group and you want to join, just send me a WhatsApp on 0837908387 and I will add you. Okay, let me stop the recording, but if you want to ask anything, please do. Else, that is it for tonight, and stay warm.
Thank